Once again, this is Jove, and in this video I'm going to teach you how you can use Scilab, in evaluating matrices. So we all know that matrices is part of linear algebra. So if you are doing some practice solving matrices or matrix manually, then we can use Scilab to evaluate your answer. If your answers done manually is equal to the answer given by Scilab, then the manual calculation is correct. Now Scilab is used in this video so that we can be able to compare if our answer done manually, which is very time consuming, is correct. But one way of mastering the matrix operation is by manual practice. So if you want to know the immediate answer of your answers done manually, then you can use Scilab to verify those. Now in this video, I'm going to discuss first some basic concept of matrix before we go into the manual calculations by giving you some examples, and then we will verify if our answers are correct, which is done manually. So let's get started. All right, so on my left, I'm using Active Inspire Studio as my digital whiteboard so that I can use this as my writing paper. And on my right, I'm running Scilab 6.1.0 console Scilab. Okay, so introduction to matrices. Sorry for the spelling, it should be matrices. So matrix of order m by n or an m by n matrix is actually a rectangular array of numbers or elements having m rows and n column, which can be represented in the form. Generally, matrix can be represented by this form using bracket, and for example, this is the element A11, A12, A1 sub 3 up to A1 up to n, right? And then A21, row 2, A22, row 2 and column 2, and A23 up to A2 up to n, up to AM1, AM2, AM3, up to AM sub n. So up to here. So this is general representation of a matrix where m by n is the size of the matrix. So m here represents the row and n is your column. Right? Now, since this is the size of the matrix, okay, now each number or a sub jk is the element in a given matrix is called an element, where subscript jk indicates respectively the rows and column. So in each matrix, there is what we call an elements, which is represented by a sub jk, and j is the row and k is the column. All right, so if we have a jk, okay, for example, if you have j is equals to 1 and k is equals to 1. So therefore, the elements of the matrix will be A, 1, 1. So that is the elements, A, J, K. Okay, so let's have some example. So for example, we have a vector. We have the size 2, for example, 2, 4, 6. And then we have 8, 10, and then we have 12. And then we have -2, 5, 6. So we have 3 by 3. In this case, 3 rows, 3 by 3. This is the size of the matrix. Now, in order for us to get the elements, for example, we want to get the element, what is the value of the element A12? The value of A12, element A12, that means this is row 1, this is the row 1, and then column number 2. Row 1, column number 2, so the intersection actually of that is 4. So therefore the answer is 4. For example, we want to get the value of the element 3, 2. This means this is row 2, row 3, and this is column number 2. This is the row 3 and column number 2, this one. The intersection is 5. What about 3, 2? What is the value of the elements in A32? Row number 3, column number 2. Same, sorry. So this is the same. So let's say this is 3, 1. Change 3, 1. Row 3. This is row 3, column number 1. So the intersection is this one. The value is -2. Okay, so now let us verify using our Scilab. So first we need to define the vector. In Scilab, we can define vector which is equal to using bracket, and then we have 2, 4, 6, and then separate the first row by the use of semicolon, and then 8 space 10 space 12, then semicolon again, and then -2, 5, and 6. Closing bracket, and then hit enter. So this is our vector, a matrix. So if we're going to get the elements of A12 using our vector, is that the command in Scilab is we are using vector A. So what is the element of 1, 2? The value is 4. So we are using capital A because we define here the vector. So in the manual, we represent the small letter A as the element. So A12 is equals to 4. So if I'm going to use 3, 2, that means row 3, column number 2, our answer is 5. Let's see, so it's correct. So another one is 3, 1. That means row number 1 and column number 1. Row number 3 and column number 1. The value is -2. So this is called the matrix indexing. For example, I want to get the whole value of the first column. Colon, then space, I want column number 2. Okay, so that means all the value, all the rows of column 2 is 4, 10, 5. What about if I want column number 3 and all the rows? Rows of 3, all rows in column number 3. So -2, 5, 6. Okay, so that is how we can use the indexing or getting the elements of a vector in Scilab. All right, so let's go back again. So that is how we represent here in concept the elements JK. So in matrix, it's a little bit different representation, but the command is you have to use the vector, the one the vector you define in Scilab. All right, and then let's proceed with the operation of what are the different operations applied in matrices. Of course, we have the addition of matrix or matrices. Now, if A is equal to the element of A times JK and B is equals to the element B JK, our matrices of the same order, take note of the same. When we say the same order, the same size, we're talking about of the size of the matrix. Then the algebraic sum of A and B is equal to AJK plus BJK. So we just have to get the sum of the element of A plus the element of B. Okay, commutative and associative law of additions for matrices holds true, such that if you have matrices A, B, and C, A plus B is equals to B plus C. So commutative laws of addition applies. And the associative law is also A plus B plus C is equals to A plus quantity B plus C. So commutative and associative law for addition of matrices are valid. Okay, so let's have some example of addition of matrix. Let's go to addition of matrix. Excuse me. So for example, I'm going to define A again. This time the value of my matrix is 2, 4, 6, and then we have 8, 10, 12, and then we have 14, 16, and 18. This is my matrix A, and then I need another matrix. Let's say this is 1, 3, 6. And then we have 9, 12, and 15. And then we have 18, 21, and 25. Okay. So these are my two matrices. So I have 3 by 3 here. And I also have 3 by 3 matrix here. So they are the same size. So according to the concept, we just need to add the elements of A to the elements of B. So A plus B is equal to, the first element is 2 for A plus 1, the element of B, plus 4, the second element of A, plus 3, the second element of B, and then 6 plus 6. Okay, second row, 8, first element of A plus first element of B, second element of A plus second element of B, plus 12, and then 12 plus 15, the second element of B. And then the third one is 14 plus 18, the element of B, and then 16 plus 21, this is 1, and then 18 plus 25, right? And then just add. So A plus B is equal to, we just need to add, 2 plus 1 is 3, so this is the first, 7, and then we have 12. Next, this is 17, 9 plus 8 is 17, 10 plus 12 is 22, then 12 plus 15 is 27, 14 plus 18 is 32, 16 plus 21 is 37, and then we have 18 plus 25 is 43. So this is our answer. Three by 3. Okay, so let us now verify using Scilab. So let us define the, so I'm gonna clear the, so let us define vector A. So we have 2 space 4 space 6 semicolon, then we have 8, 10, 12 semicolon, and then we have 14, 16, and then 18 space close, and then define B. B is equals to 1, 3, 6 semicolon, and then we have 9, 12, 15 semicolon, then we have 18, 21, 25 close bracket. So we have the A and B vectors. So A plus B now is equal to 3, 7, 12, 17, 22, 27, 32, 37, and 43. So our answer are the same, manually and using Scilab. In Scilab, it's very easy. You just have to type the value, and then by default the variable is answer. I did not assign any sum for the vector, so it's just the same. Okay, now for subtraction, let's go back. So we've done with the addition. Subtraction of matrices, the same. If we have vector A, the elements of A, which is represented by AJK, and the matrix B having an elements of BJK, are matrices of the same size. Again, we need to have the same size in order to subtract two matrices. The difference between A and B is equal to, just get the difference of their elements, A minus B. However, the commutative and associative law for subtraction of matrices are not valid. So that means you need to be careful. The subtraction is not valid for commutative and associative law. That means A minus B is not equal to B minus A. We cannot interchange. And also the associative A minus B minus C is not equal to A minus quantity B minus C. So subtraction is different. They must be the same size, but you cannot interchange the vectors. All right, so let's have some example. Subtraction of matrix. So let's define a new value. I'm using the same representation. Vector A is equals to, let's say we have 9, 8, 7, and then we have 6, 5, 4, and then we have 3, 2, 1. And my second vector is equal to 3, negative 6, 1, negative 2, 5, and negative 7. And we have negative 1, 4, 3. So again, they are the same size, 3 by 3, 3 by 3. So it satisfies the condition. We can subtract A from B. So therefore, A minus B, just subtract the elements from B to A. So we have the first element of A minus 3. All right, and then 8 minus 6, and then we have 7 minus 1, then 6 minus 2, and then we have 5 minus 5, 5 minus 5, and then we have 4 minus 7, and then the third row, 3 minus 1, and then 2 minus 4, and then we have 1 minus 3. Okay, so let's simplify. Simplify the operation is equal to 9 minus 3 is 2, and 6, sorry, 6. 8 minus minus is plus, so this will become plus. 8 plus 6 is 14. 7 minus 1 is 6. Alright, 6 minus minus will become 1. 6 plus 1 is 7. 5 minus 5 is 0. So this become plus. 7 plus 4 is 11. And then minus minus becomes plus. So this is 4. 2 minus 4 is negative 2. 1 minus 3 is negative 2 as well. Alright, so this is the difference. Now let us verify in Scilab. So I'm going to clear the value, and I will define again the value of my new vector is equals to 9 space 8 space 7 semicolon, and then 6 5 4 semicolon 3 2 1 semicolon, then close bracket. So that is the vector A. Vector B is 3 space negative 6 1, and then we have negative 2 5 negative 7, then negative 1 4 3. Alright, so we have the two vectors now. Now let us apply minus A minus B. The answer is 6 14 6 7 0 11 4 2. So our answer is correct. So if you are reviewing and practicing addition and subtraction, you can use Scilab to verify immediately your answer, if your answers are correct, because manual we are prone to mistakes. Okay, now let us proceed with another concept, which is the multiplication of scalar. Matrix multiplied by scalar. Scalar means this is a constant value. So if matrix A is equals to AJK, where AJK is the element of the vector A, is multiplied by any number of its scalar K, then the product will be matrix P is equals to K multiplied by AJK. You just need to multiply all the values of the elements of vector with a constant value K. Okay, for example, I'm going to use this space. For example, we have the vector A is equals to 9 8 7, and then we have 6 5 4, and then we have 3 2 1. And then, for example, we have 3 multiplied by the vector A. So the value of that, just multiply 3 to the given value of the vector 6 5 4 3 2 1. So therefore, 3 multiplied by 9 is 27. 3 times 8 is 24. And then we have 21. 7 times 3 is 21. 6 times 3 is 18. 15. 3 times 4 is 12. And then 9, 6, and 3. Okay? So let us verify using Scilab. Again, in Scilab, I need to clear the value again so that the new value will be accepted by. So again, I need to define 9, 8, 7, semicolon, space, sorry. And then, wait. Let's see. I need to clear this one. Exit. I need to open new. Yes, and then just open it again. A is equals to 987 colon then 6 space 5 4 colon and then we have 3 space 2 1 10. Oh, we need to have the value A, quantity A. All right, and then 3 multiplied by A. What is this? 3 in Scilab, we should have the symbol asterisk to multiply. So our answer is correct, 27. So scalar multiplication of matrix is simple. Just multiply each element of the given matrix. All right, so now let's proceed with the multiplication of matrix. In multiplication of matrix, the same if we have a vector A or matrix A having the elements AJI is an M by N matrix, and B is equal with the elements BJK is an N by P matrix, then the product of A and B is equal to matrix C. So the product of the elements of A and B will be CJK. Okay, and then an M by M matrix will be resulted. So the general form of this multiplication of matrix is actually, the general form is, we can write the general form CJK is actually equal to the summation of J is equals to 1 up to P, row up to the column P of A multiplied by JI multiplied by BJK, where where J is equals to the value 1, 2, 3 up to M. Okay. And then the value of K is equal to 1, 2, 3 up to P. So these are the elements from 1, 2, 3 up to M and then K. These are the elements of the product of two vectors. Generally, this is the general form of the product. The multiplication of matrix A and B is also equal to AB is defined if and only if the number of columns, take note of this, the number of columns of A is equal to the number of rows of B, such that the matrices are said to be conformable. So the number of columns of A must be equal to the number of rows of B. So the first column, the number of rows, a column of A must be the number of rows of B to be valid. Otherwise, you cannot apply multiplication if they are not equal. Okay? The commutative law of multiplication of matrix is not valid. Hence, AB is not equal to BA. So you cannot interchange also the two vectors if we are multiplying the two matrices. Or the two matrices is not interchangeable. However, the associative and distributive law are valid such that matrices A, B, and C, associative law is valid. AB multiplied by C is equal to A quantity B multiplied by C. So this is associative law for addition also holds true in multiplication. All right, so let's have some example. So example of multiplication. So let's have for example, we have A is equal to, let's say 2, 4, 6, and 8. And then my second vector is equals to 5, 4, and then we have 3. 1, 2, and we have 3. Okay, so this is 2 by 2 matrix and this is 2 by 3. According to the concept of multiplication, the number of columns of vector A, in this case 2, must be equal to the number of rows in the second vector, this one, 2. Since n, which is equal to 2, are the same with vector A and B, then we can apply multiplication of these two matrices. And the result will be 2 by 3 matrix. So we are expecting that the result of this two multiplication is 2 by 3 matrix. So therefore AB is equal to, according to the definition, we need to multiply each element of A to each element of B. So therefore 2 multiplied by 2 multiplied by 5, right, plus, so this one 2 multiplied by 5, then plus, we need to add summation, if you remember, plus 4 multiplied by 1. Okay, so that is the first row. And then we need the second column now. 2 multiplied by 4 plus 4 multiplied by, 4 multiplied by 2 multiplied by 4, and then 4 multiplied by 2. This one, 4 multiplied by 2. And then we have 2 multiplied by 3, third column, plus 4 multiplied by 3. Okay, so 4 times 3. Is it correct? 2 times 5, 4 times 1, 2 times 4, 4 times 2, and then 2 times 3, and then 4 times 3, or 3 times 4, okay? Next is the second one, the second row. 6 multiplied by 5 plus 8 multiplied by 1, and then 6 times 4, and then plus 8 multiplied by 2. And then the next one is 6 multiplied by 3 plus 8 multiplied by 3. 6 times 3 and 8 times 3. 6 times 3 and 8 times 3. Okay? And then just get the sum. Is equals to 2 times 5. This is 10 plus 4 is 14. And then we have 8 plus 8 is 16. And then we have 6 plus 12. 12 plus 6 is 18. And then we have 6 times 5 is 30 plus 8. We have 38. Is it correct? 8 times 1 is 8, yeah, 38. And then 24 plus 16, we have 40. And then we have 18. 6 times 3 is 18 plus 24. 18 plus 24 is 42. So that will be our answer. Let us now verify using Scilab. So again, I'm going to clear. Then CLC. Now again, let us define A is equals to 2 space 4. And then we have 6 and 8. So we have 2 by 2 vector, and then the B is equals to 5 space 4 space 3 semicolon 1 2 3. Okay, so we have 2 by 3. So if we're going to multiply A multiplied by B, the answer is 14, 16, 18, 38, 40, 42. So our answer is correct. So in Scilab, we can easily verify, as you can see. All right, so that is for multiplication. The last topic is about transpose. Transpose of a matrix. Transpose of the matrix is actually the resulting matrix when the rows and columns of a given matrix are interchanged, and is denoted by denoted. That is not donated. Denoted by A raised to T, such that the vector A is equals to the element of A jk. Then A raised to T is equals to A kj. So it was interchanged. The row becomes the column, and then the column becomes the row. So for example, we have again the vector. So for example, we have the vector A is equal to 2, 4, 6. And then we have 1, 2, 3. So the transpose of this vector is equal to, just interchange the row by column. So it becomes, the transpose of this is, the column will become the row. This column will become the 2, 4, 6 will become row, the vector. And then this one will become 1, 2, and 3. So this is 3 by 2 and becomes 2 by 3. So this is basically the transpose of a matrix. Just transpose, the column becomes row, and then the row becomes column. Okay? So let us try if we can verify in, let's verify in Scilab the transpose. Clear. CLC. So for example, let us define two, 1. Then we have 4 space 2. Then we have 6 space 3. Okay, so this is the matrix. I think A. So in Scilab, the command is A apostrophe to transpose the matrix. So our answer is 2, 4, 6, 1, 2, 3. So it's correct. Okay, so that's it. So in this video, you learn the basic concept of matrix and how we can use Scilab to verify our answer that is done manually to the using Scilab. So this is very useful, especially if you are preparing for board exam, preparing for examination, and you want to practice more the skills of adding, subtracting, and multiplying the matrices. Use Scilab for you to be able to verify if your answers are correct. So that's all for this video. Thank you so much. I hope you learn a lot from this video. So I hope you learned something in this video. So in my next video using Scilab, I'm going to use Scilab for use in adding polynomials. So thank you so much, and see you on my next video. Please don't forget to subscribe in my YouTube channel and hit the notification bell so that you will be updated in my future uploads. Thank you so much.